Astronomers have catalogued over 5,000 planets beyond our solar system. They have pointed telescopes at hundreds of billions of stars. They have listened to the cosmos for decades, with instruments sensitive enough to detect a whisper from the edge of the universe. And after all of that, the answer is always the same: silence. Just one small, living world, drifting through an ocean of empty darkness. The question that no one can fully answer is why only here? Why only us? Why only Earth? If that question keeps you up at night, you are in the right place. Welcome to Space Review. Subscribe and hit the bell so you never miss a deep dive like this one. Most people have heard of the habitable zone, the orbital sweet spot around a star where temperatures allow liquid water on a planet's surface. Earth sits comfortably inside it. But here is what the textbooks leave out. Venus is also close to that zone, and Venus is one of the most hostile places in the solar system. Surface temperatures hot enough to melt lead, atmospheric pressure 90 times that of Earth, clouds of sulfuric acid. Being in the right location is necessary, but it is nowhere near enough. Something else is keeping Earth alive, and it starts deep underground. At Earth's core, a churning ocean of liquid iron generates a magnetic field that stretches tens of thousands of miles into space. That field is an invisible shield, deflecting the solar wind, the constant stream of charged particles streaming off the sun. Without it, the solar wind would gradually strip away our atmosphere, the same way it appears to have done on Mars. Mars once had rivers. Ancient geology tells us that clearly. But it lost its magnetic field billions of years ago, and the solar wind slowly bled the planet dry. Today, Mars is a frozen, airless desert. Earth kept its shield. Mars did not. That difference is life and death on a planetary scale. Now here is the part that sounds almost too convenient to be real. Earth's magnetic field exists partly because of something that almost did not happen at all. About 4.5 billion years ago, a Mars-sized object crashed into the early Earth in a glancing blow. The debris from that collision eventually became the Moon, and the Moon does something quietly critical. Its gravitational pull stabilizes Earth's axial tilt at around 23.5 degrees. Without that stabilizing force, our tilt could swing wildly over millions of years, triggering climate chaos so extreme that complex life would struggle to ever gain a foothold. That moon was born from a random collision. Hit us at a different angle, the planet might have been destroyed. Miss us entirely, and we likely have no moon, no stable tilt, and a very different story. One cosmic accident, billions of years ago, and everything changes. There is one more protector most people never think about, and it sits 400 million miles away. Jupiter, the largest planet in our solar system, is so massive that its gravity acts like a cosmic goalkeeper. It captures and deflects asteroids and comets that would otherwise pummel the inner solar system far more frequently. Without Jupiter absorbing those impacts over billions of years, Earth would face extinction-level collisions so regularly that life would barely have time to breathe before being wiped out. Jupiter has been quietly taking hits for us since the solar system formed. Even with all of that protection, life still needs something more fundamental than anything else: water. Earth has it in extraordinary abundance, and water is not just a convenience. It is the medium in which chemistry becomes biology. It has a unique property that almost no other substance shares. It expands when it freezes, meaning ice floats. That single fact means that during ice ages, a layer of ice insulates liquid water below, and life survives. If ice sank, oceans would freeze solid from the bottom up, and life would have nowhere to hide. But perhaps the most underappreciated ingredient is time. The first living cells on Earth appeared roughly 3.8 billion years ago. Complex multicellular life only emerged 600 million years ago. Humans have existed for a mere 300,000 years. For life to go from a simple cell to a civilization, you need billions of years of stable conditions. That kind of uninterrupted stability on a planet shielded by a magnetic field, stabilized by a moon, guarded by a giant neighbor, orbiting a calm and steady star, may be extraordinarily rare. Science is getting closer to answers. The James Webb Space Telescope has already detected carbon-based molecules in the atmospheres of distant exoplanets. NASA's Perseverance rover is drilling into ancient Martian lakebeds, searching for chemical traces of life that may have existed billions of years ago. Europa, a moon of Jupiter, hides a global liquid ocean beneath its icy surface, kept warm by tidal forces. The Europa Clipper mission, launched in 2024, is heading there right now to investigate. Enceladus, a moon of Saturn, is actively spraying water vapor and organic molecules into space. None of this confirms life beyond Earth, but it confirms that the ingredients are out there. The question science is now asking is not whether the conditions exist, but whether life actually takes hold when it gets the chance. Earth is not special because of one thing. It is special because of everything at once. The right distance from a stable star, a magnetic shield, a moon born from catastrophe, a giant planetary guardian, oceans of liquid water, plate tectonics recycling the atmosphere over billions of years, and enough time, undisturbed, for something as improbable as a conscious mind to emerge and ask why it exists. We may yet find life elsewhere. The universe is vast, and we have barely scratched its surface. But until that day comes, Earth is the only place in the known cosmos that has taken the raw dust of dying stars and turned it into something that breathes, and wonders, and looks up. That is worth thinking about next time you step outside. If this made you see Earth differently, share it with someone who needs a reminder of how remarkable this place is. Comment below with the one thing you think makes Earth most unique, and subscribe to Space Review, because the next question we are exploring is one scientists have quietly disagreed about for years. You will not want to miss it.